Today we are going to learn about operations of set. In that we are going to see intersection of sets. Now what is this intersection of sets? The set of common elements of given sets is called the intersection of set, and it is denoted by the symbol like this upside down U. So it's U, but it's not normal U, ulta U, upside down U. And how we can define this using the rule method? This, suppose the given sets are A and B, then it is read as A intersection B is equal to, it's a set of all X such that X is element of A and X is element of B. So we are going to collect such elements which are the elements of A as well as B to given set. Let's see the example. So if A set is 2, 1, 2, 3, 4, 5 and set B is 2, 3, 5, 7. Now let's see which are the common elements. Is 1 in both? No. 2, yes, we can find this 2. Let's underline these common elements. 3, yes, it is in both sets. 4, no. 5, yes. So we have this 5. This set is over here and this is extra. So this set of underlying elements 2, 3, 5, these are the elements common in both. So these 3 elements are elements of set A as well as set B. Therefore, if we take this set of these 3 elements, we write A intersection B, it's set of 2, 3 and 5. So these are the common elements of set A and B, and this is the set which is called A intersection B. And we can see that we have used this symbol of intersection. Now if we want to show this using Venn diagram, how we can show? Suppose I am showing this set A by a circle, set A, and set B another circle. Now as we have these 3 elements common, some part of A and some part of B are common. So let's draw 2 intersecting circles each other like this, and suppose this set B. Now this part specially is a part of both circles. Okay, it means it's part of both 2 sets A and B. So here in this between, we can write the common elements which are 2, 3 and 5. So these 3 elements are common to set A as well as set B. And what are the remaining elements of set A? Remaining elements are 1 and 4. We can write it here, 1 and 4. So this 1, 2, 3, 4, 5 set A. Let's see which are the remaining elements of set B. 7 is the remaining element which will come in this remaining part of the circle, 7. So set B consists of this 2, 3, 5 and 7. So this way we can show the intersection part. The highlighted portion is called as A intersection B. So this is our A intersection B. Sometimes we have not given element, but still we have to show by Venn diagram. In that case we can show 2 sets intersecting each other, and this common part we can show by A intersection B. So this is the common part. Now let's take another example. If P is set of 1, 2, 3, 4, 5 or till 10, all these natural numbers till 10, and Q is a set of 1, 4, 9, then what is P? The symbol stands for intersection Q. Now we can see that 1 is common, 4 is common, and here 9 is also there, which is common. So in intersection we have all these 3 elements, and if we take the set of 1, 4, 9 common elements, this is our set, intersection set. Now if you observe that in this intersection we got all elements of set Q, therefore we can say here that P intersection Q is nothing but it is equal to Q. In that case we can see that Q is subset of P. Therefore we can say Q is subset of P, as all the elements of Q are the elements of set P. So here the subset relation we can find. How can we show this? Using Venn diagram. We already have seen. Let's see once again. So suppose this is the bigger is say P set, and inside that if we have this Q set, in Q we can write say 1, 4 and 9, and remaining numbers out of the circle. that is 2, 3, 4 we have, 5, 6, 7, 8, 9 we have here, and 10. And this is our intersection part. Okay. Now let's take the third example. Let set X is a set of 1, 3, 5, 7, 9 and set Y is a set of 2, 4, 6, 8, 10. Then what is A intersection Y? X intersection Y. Now 1, no common. 3, 5, 7, 9. So we find that no element is common. So in that case, now X intersection Y will be an empty set. Either we can show by this way or we can show it by symbol of 5, that is an empty set. In such case, we can show this using the Venn diagram, that X set separately and Y set separately. Elements of set X are 1, 3, 5, 7, 9 and elements of Y are 2, 4, 6, 8 and 10. Nothing is common, so we have two different close figures of set X and Y. So here there is nothing common. Intersection is an empty set. In such case, we call that set X and Y are disjoint set. Disjoint set. Okay, the name only suggests you they are not joint. They are completely different. Disjoint. Nothing is in common. So we use this specific word in that case. Okay. Now let's see some properties of intersection of sets. All these properties are in the textbook. I just want you to explain. As it is given with the help of symbol, let's understand the meaning of it. First property is A intersection B is equal to B intersection A. So intersection of A and B, whatever set we get, is same whatever intersection of B and A. So A intersection B and B intersection is going to be same. This is the first property. If A is a subset of B, then A intersection B is going to be A. So A is such a set that all elements of set A are the elements of B, then here the intersection is going to be the smaller set A. As here we have in this example that Q was the all intersection of P and Q, we got it Q. So Q is the smaller and all the elements of Q are the elements of P. So Q is a subset of P. Similar we have written using the letters A and B. And vice versa, means if we find that if it is given that A intersection B is B, suppose we have A intersection B is B, means a set of common elements of set A and B is equal to B. In that case, B is the smaller set and all the elements of B are the elements of A. Hence we can say B is subset of A. Suppose instead of B letter here if we have A, then we can have A is a subset of B. So whichever is intersection, that set is going to be the subset of the other set. Now what is the fourth property? A intersection B is subset of A. Now this is set A, set B. Any set A, any set B. This is the intersection. Now this intersection set is subset of given set A as well as this is subset of given set B. The same, this is the property we have. So set intersection set, this set is subset of A as well as A intersection B. This is subset of B. Okay. Now let's understand what is the fifth property. A intersection A dash. What is the meaning of A dash? It's complement. We have learned in that universal set, if for the given universal set, whatever elements of set A and the remaining elements, we put it into complement of that. So A and A dash are two sets which are disjoint. We don't have anything common. That's why its intersection is an empty set. Okay. And what is A intersection A? Whatever set A, its intersection with itself is going to be whole A. That is going to be A set. And the last property, any set A intersection with empty. First set is any set A. And the another we are taking intersection with empty set. So empty set we don't have anything. That's why its intersection common elements will be nothing. And that's why this equals to again empty set. Thank you.